All right, we are going to talk about our same 6 trig functions that we've been talking about. This is going to seem a little redundant again, but we're going to talk about some different mnemonic devices, like PEMDAS is a mnemonic device to remember stuff. You guys are going to have to think a little bit more in this section than math computation, but it's nothing you guys can't do, I promise. Any sign of any trig function, any part of your coordinate plane, you can figure out in your mind. If I said to you, without looking at this, if I said to you guys, what's the tangent of any angle in quadrant 3? Well, think about what tangent is. Tangent's what over what? Well, let's think about x, y, and r. Tangent's y over x, right? So if you have y over x, if y is negative and x is negative, then your tangent's going to be positive. So like in quadrant 1, everything is positive, right? Because your x and your y values are positive. In quadrant 3, your tangent happens to be positive because you're dividing 2 positive numbers, right? You guys see that? You could figure out anything in any quadrant because of the signs of x and y. So there's a mnemonic device that you can think of. They use all students take calculus. If you think about this, in the first quadrant, because your x values and your y values in quadrant 1 are both positive, right? Agreed? That means all 6 trig functions are positive. Sine, cosine, tangent, and their reciprocals. In quadrant 2, we say all students take calculus. You put an S here. Because in this quadrant, x is negative, but y is positive, right? So what trig function starts with S? Sine, and what's its reciprocal? Cosecant. See, right. So in quadrant 2, sine and cosecant are positive, and everything else is negative. All students take. In the third quadrant, I have negative, negative, right? So what trig function starts with T? Tangent. So tangent and cotangent are positive here. Everything else is what? Negative. All students take, and then we'll say calculus. So C. Because over here, your values for x are positive, but your y is negative. So in the fourth quadrant, cosine and secant are positive, and everything else is negative. You guys see that? So move on, guys. If you have questions on your WebAssign, you'll have a question on your test. That looks like this. There's absolutely no numbers here, guys. It says name the quadrant in which theta lies, and they give you 2 parameters. They give you 2 rules, all right? So I'm going to draw myself a coordinate plane, and I'm going to say, all right, so all students take calculus. This is how we would figure this out, guys. Look at the first parameter. You will be able to do this with every single one of these problems. You can eliminate 2, and then you can eliminate 1, and you'll be able to figure out what it's saying. But we're talking that this angle, this whatever theta, lies in a quadrant that cotangent is greater than 0. What does that mean? Cotangent would be what if it's greater than 0?
Positive.
Positive. So let's figure out where cotangent is not positive. Where are the 2 places where cotangent is not positive? S and C. You guys agree?
Yes.
In the first quadrant and the third quadrant, tangent and cotangent are positive. So then your second piece of information says sine is less than 0. That means sine would have to be what? What does less than 0 mean? Negative. Negative. Where is sine in the 2 that are remaining? Where is sine negative? Down here. Because what's going on in this first quadrant? Everything is what? Positive. So you just figured out that this theta lies in quadrant 3. All right, so here's a problem that you'll see. Now, there's very minimal computation here. But it says, given that cotangent of theta is negative 4 over 3, and sine is greater than 0, find the following. So they're telling you guys a lot of information. The first thing they're telling us, let's write down cotangent of theta is negative 4 over 3. What are the 3 values you need to find all the trig functions? X, y, and r. Okay, so I need x, I need y, and I need r. They gave me two of them already. What'd they give me? They gave me x and y. Which one's x, which one's y? X is 4 or -4. We don't know which one. And y is the 3, right? So this is why I say we don't know which one. Because I said to you guys yesterday, and I made a point to say this, it doesn't matter where the negative is. It could be in the top. It could be in the bottom. It could be out in front. You don't know where that negative goes. You do know that x is 4. You do know that y is 3. But you don't know which one is which. This second piece tells you which quadrant is which. So think about this, all right? The first thing they told me, all students take calculus. This is where you got to think a little bit. They told me that the cotangent is what? Negative. So you know it can't be in which two quadrants? Can't be in A because everything's positive there, and it can't be where else? In T. It can't be the third one because that's positive. So the second thing they told me is that sine is greater than 0. What does that mean? Sine is what? Positive. In the two that are remaining, where is sine positive? S, up here. So think about the signs, positive, negative, of something in the second quadrant. What is positive and what is negative? No, tell me x and y. What's positive? In the second quadrant, x is negative, right? And y is positive. So in this case, your x is negative and your y is positive. If it was in the fourth quadrant, do you see how the negative would be on the y? Yeah. So guys, if you just miss that little tiny piece, then all of your trig functions will be wrong. So now that we figured that out, now we can figure out what r is. We've done this special triangle a million times. I have -4 squared plus 3 squared equals r squared. -4 squared is 16 plus 9 equals r squared. What's 16 and 9? 25 equals r squared, so r equals 5. Now you have everything you need. You guys can find all the trig functions real easy. Sine is y over r. Cosine is x over r. What does secant go with? Cosine, so r over x. And what does cosecant go with? So r over y, right? So the sine is what? 3 over 5, good. What is the cosine? -4 over 5. What is the secant? 5 over -4. And what is the cosecant? 5 over 3. Now the math computation behind this, not hard, but you guys do have to take a second to think. Where is this stuff located? Okay. Now we're going to talk about reference angles. And you need reference angles when you're trying to find out trig functions of special stuff. All right, we'll talk about it in a second. But there are two things that are really, really, really important about reference angles. Okay, values of trig functions of angles greater than 90 can be determined from the values corresponding acute angles called reference angles. Right here it says let theta be an angle in the standard position. A reference angle is an angle. Look, it's noted like this. Little theta prime, and it's formed by the terminal side of theta and the horizontal axis. Let me show you what this means. Do you guys see right here this angle? This that I have in green. It's in the second quadrant, right? It's bigger than what? 90 degrees. So your reference angle would be drawn from the terminal side, which is right here, down to the x-axis. So do you see this little angle that's right here? This is what's called your reference angle. In this second example, do you see this angle here? This whole thing is this angle given. So your reference angle is drawn from the terminal side to the x-axis. So it goes up here like this. So your reference angle is right there. In this third example, you have this whole big angle. So your reference angle, again, is from the terminal side to the x-axis. Now, the way that we find reference angles, I'm going to show you. There's two things about reference angles that are really important. You need to write this down. Reference angles are always acute. What does that mean? Less than 90. And they're always positive. So you guys are going to figure out reference angles mathematically, and then we're going to use reference angles to find some trig functions of stuff. But this is a really easy concept, and I'll show you. I'll write out a little. Let me go back here. Okay, here's our reference angles. Quadrant 1. Theta, if the given angle is in quadrant 1, then that given angle is the same value as your reference angle. Because think about it. Reference angles are always... Okay, so reference angles are always positive and always acute. So if I told you that theta was 47 degrees, what is the reference angle? You guys would tell me the reference angle is how much? 47 degrees. Because think about this. In the first quadrant, right, my angle's here. Your reference angle is drawn from the terminal side to the x-axis. So in quadrant 1, if the angle is in between 0 and 90 degrees, whatever theta is, that's going to be your reference angle. So quadrant 2, if theta is in quadrant 2, the way that you find the reference angle is 180 minus theta. Now guys, if they gave you your angle in radians, what would you have to use instead of 180? Pi. Or you could do what? You can convert it to degrees, find out what it is, then convert it back. If your angle given to you lies in quadrant 3, your reference angle is whatever theta is minus 180 or pi. So depending on where the angle is, if it's in quadrant 2, you say 180 minus. Because remember, there's two things you have to remember. Your reference angle is always going to be positive and always going to be acute. So if you're in quadrant 3, think about if you're in quadrant 3. Quadrant 3 is over here. This is 180 and this is 270. If you have an angle of 245, if you say 180 minus 245, you'll get what kind of a number? A negative. Can that be a reference angle? Because reference angles have to be what? Positive and acute. We only use 180 or 360. We don't use 90 or 270. So remember that. Only things on the horizontal. We don't use anything on the vertical. So if you subtract and you get a negative number, then you might think, whoops, I should flip it. If your angle is in quadrant 4, okay, if your angle is in quadrant 4, you say 360, or what's the equivalent to 360? 2 pi minus the angle, and that'll give you your theta.
Minus the angle?
Yeah. So like if your angle was 315, you would say 360 minus 315 and get a nice positive acute number. It's here in a second. Let's work through some of these examples. Look, I got 300. Okay, think about 300 for a second. If you can't visualize it, draw it. Where is 300? This is 90, 180, 270, and 360. Where is 300? It's over here in quadrant 4. So what is the rule for quadrant 4 to find the reference angle?
360 minus 300.
You would say it's in quadrant 4, so I'm going to say 360 minus 300, and I get what? 60 degrees. Now check to make sure. Is that number positive? Yes. Is it acute?
Yes.
Yes. So there's your reference angle. That's it. We'll come back to 2.3. Negative 135. Well, here we go, guys. We got those darn negatives again. If I have a negative, which way am I going?
Clockwise.
The opposite direction, right? Clockwise. So it's 0, negative 90, negative 180, right? Negative 270. Where is this angle? It's over here in quadrant 3, right? So what's the rule for quadrant 3?
The degree minus 180.
The degree minus 180?
Or not.
180 minus
Theta minus, which one is it?
180 minus theta.
Theta minus 180. So my theta is negative 135 minus 180. What do I get? A negative number. How do you find the coterminal angle? Negative 135. How would I find a coterminal? A positive one. I would add 360. Look at you. What's 135 plus 360? We get 225 degrees. Okay, all right. Now we're working. Let's think about this. 0, 90, 180, 270. Where is 225?
Third quadrant.
It's in quadrant 3. It's the same angle as negative 135, right? Just the opposite direction. Now can we use our little rules?
Yes.
How do you find a reference angle if it's in the third quadrant?
Theta minus 180.
It's theta minus 180. What is 225 minus 180?
45.
45 degrees. Is that positive?
Yeah.
Is that acute?
Yes.
Good thinking. Very good job. So, guys, what should you do when you start off with a negative angle?
You should
Add 360.
You should add 360. Find the positive. Very good thinking.
So when it's negative, you add 360.
Hold on one sec. Find the positive coterminal. That was awesome. Good job, Andres. Raul, question? All right, here we go. Like we just talked about with when we have pi. All right. Right now, find the reference angle for theta. Sketch it. You don't need to sketch right now. I just want you. Well, I mean, we will, but where is 2 pi over 3? You guys don't have a unit circle in front of you. You have no idea what quadrant that is. How can we figure that out? We can convert it. Let's convert it to degrees. How do I do that? Pi on the bottom, 180 on the top. Okay, good. We need to get a visual on where this angle is. Now, my angle started off in radians, so I need to finish in.
degrees.
No. If it starts in radians, I need to what? Finish in radians. So we're going to have to convert back, but that's okay. So pi's will cancel. Can I do any simplifying here? 3 goes into 180 how many times?
6.
60. So 2 times 60 is 120. Where is the angle 120 degrees?
In the same quadrant.
It's in quadrant 2. It's between 90 and 180, right? So in quadrant 2, guys, what's the rule for quadrant 2?
Minus theta.
What is it? I'm sorry?
180.
180 minus theta, which is 120. What's 180 minus 120? 60 degrees. Good. Now, can I leave my answer as 60 degrees?
No.
Why not?
Back to radians.
Because we started off in radians. So real quick here at the end, I just have to go, whoops, we got to go back. I need my degrees to cancel out.
And then minus 80.
So look, my zeros will cancel. 6 goes into 6 once. 6 goes into 18 3 times. So my reference angle is pi over 3. Very good, guys. Very good. Okay, look at this next example. Oh my gosh. 23 pi over 6. That's a big old number. Do I have any idea how many times around the unit circle we're going on this one? Nope, so let's figure it out. Let's convert it to degrees. So pi cancels, 6 goes into 180 30 times, right? What's 23 times 30? 690 degrees. Well, what do you notice about 690?
It goes around.
It goes around the circle more than once. So let's subtract a whole circle. See if that helps us out. What's 360? Sorry, 390 minus 360. 330. Is that less than one whole circle? Okay, so let's think about this. Here's 360, here's 270, 180, and 90, right? 330 is going to be over here. In which quadrant? Quadrant 4. What's the rule for quadrant 4? 360 minus theta, which is 330. 360 minus 330 is 30 degrees. My answer began in, so my answer needs to end in radians. So look, 30 over 1, and then we have pi over 180, right? So I'm going to cross this out. 3 goes into 3 once. 3 goes into 18 6 times. So I'm left with pi over. There you go. Good job. Okay, now it says to see how you can use a reference angle. Okay, we talked about this a second ago. We talked about how reference angles were drawn, correct? If you guys notice, all of our reference angles that we were just given, we ended up with like 45 degrees, 30 degrees, 60 degrees. What kind of triangles do we have that have 30s and 60s and 90s in them, and 45s and 45s and 90s? Special rights, okay? So think about this. We're going to draw reference angles. So right here is where our angle is formed, right here at the origin, right? So from the origin where our angle is formed, this would be opposite, this would be adjacent, and R is always our hypotenuse, right? So we're going to use what we just learned from reference angles to determine trig functions, okay? These next few slides, just telling you what I'm saying. Depending on the function associated with the reference angle, you can figure out special right triangles. You're free to memorize this chart. I don't know if that's probably the best thing in the world to do, but this is a chart so you can understand what the sine, cosine, and tangent is of your angles in radians and degrees for your specials, for your 30, 60, 90s, and your 45, 45, 90s. You guys will not be given a unit circle on your test, so you're going to need to know how to figure that out. I added this slide in here so you guys can remember that across from both of the 45s, your legs are the same length. Whatever's across from the hypotenuse is that leg length times 2, right? Across from the 30 is the leg length. Across from the 60 is the leg length times root 3. And across from the hypotenuse is 2 for a 30, 60, 90. You actually don't need to know anything other than across from 45 and 45 is what number? What do you see? What number? On the unit circle, what number is it? What you're looking right at it. 1. Okay? And your hypotenuse is always what? Square root of 2. So when you have a 30, 60, 90, and we're talking about reference angles on the unit circle, you guys, this should be okay because we've drilled this into your head a little bit. But across from the 30 is 1. Across from the 60 is root 3. And across from your right angle is 2. Now watch how that works. Okay? Evaluate each trig function. What is the cosine of 4 pi over 3? They don't want a decimal. It's got to have to be an exact value. So the way that you do this, you guys don't know. Let's look at 4 pi over 3. Where is that on the unit circle? Do we have any idea? No. So let's convert it first. Let's convert it to what? To degrees, okay? So 180 and pi. Pi's cancel out, right? 3 goes into 180 how many times? 60. And 60 times 4 is 240. Okay, 240 degrees. Now, that helps us because we can find a reference angle. Where is 240? It's over here in quadrant 3, right? You guys agree? Mm-hmm. So, what is the reference angle for 240? How do you find quadrant 3? 240 minus 180, and you get what? 60 degrees. All right, that's why we need to know our special rights. Think about this triangle. Why it's in the third quadrant, we need to be aware of. Do you see that this triangle right here, this angle is the one we're talking about? Yes? You guys agree with me? I'm going to redraw it right here. This angle right there is how many degrees? 60. Okay, so this is my 60. So let's think about this. We're in quadrant 3. I'm going to draw a quadrant so you can see. We're in quadrant 3. Do you guys agree with me? This is my x values. These are my y values, up and down? Yeah. Okay, so across from this 60 is what? 1, 2, or square root of 3? Okay, this is the square root of 3. Across from the right angle is what number? 2. And across from the 30 is what number? 1. Now, what are the signs of 1 and negative 3 if this is in quadrant 3? If I had to go from here and I went to the left, what is my x value going to be? My x value is going to be negative, right? And what is my y value going to be? Negative. Now, you guys had to know your special right triangle pattern, right? We had to find our reference angle, and then we had to write our pattern out. So let's go back and see what the question was even asking. Cosine. Well, in regards to 60, guys, cosine is what over what? Adjacent, opposite. What's cosine?
Adjacent over hypotenuse.
Okay, cosine of theta is adjacent over hypotenuse. So in regards to 60, what is the adjacent side? The adjacent side. -1. And what's the hypotenuse? 2. So your cosine of 4 pi over 3 is -1/2. So when you are asked, given an angle, use it to evaluate, find the cosine, tangent, whatever, you're going to have to use reference angles. It's either going to be a 30, 60, 90, or it's going to be a 45, 45, 90. Let's do this one. Tangent of -210. Well, first of all, it's a negative, so what do I have to do with this? I'm going to add 360 to it. What is -210 plus 360? 150 degrees. Whoops. Okay, so let's think about 150. Where is 150? It's over here in quadrant 2, right? Okay. So if we're in quadrant 2, grab the door, please. How do you find the reference angle? How do you find the reference angle for quadrant 2? 180 minus 150, right? So it's how much? 30 degrees. So we're talking about this angle right here is 30 degrees. Everybody agree with me? You understand where I got that from? Okay, perfect. Good job. So what kind of a triangle is this? 30, 60, 90 or 45, 45? 30, 60, 90. So what's the pattern? What's right across from the 30? 1. What's across from the hypotenuse? 2. And what's across from the 60? The square root of 3. Now think about if we're in quadrant 2, my x value is what kind of a number? Negative, but my y value is positive. Okay, awesome. We okay? So now I want the tangent of theta. Tangent. What is tangent? What over what? Opposite over. So it's 1 over -√3. Can I have that?
No.
So I'm going to rationalize. So the tangent of -210 degrees is -√3 over 3. You guys see that? Okay, you just got to draw it. We'll do one more. Lots going on. We got to think a lot. 11 pi over 4. I don't know where that is. How do I figure that out? Okay, let's convert it. So I have pi down here, 180 up here, right? Pi's cancel. What happens with 4 and 180? 4 goes into 4 once. 4 goes into 180 how many times? 45? Okay, what's 45 times 11? 495, you guys agree?
Yeah.
All right, well, where is 495 on one circle? It laps once, so let's take away one whole circle. What's 495 minus 360?
135.
135. Okay, good. So let's think about where 135 is. Second quadrant. What is the rule to find the reference angle in the second quadrant? 180 minus 135, which is what? 45. So this is the angle that we have formed right here. This is 45 degrees. Agreed? So this is my right angle, and here's my 45. Guys, what's the pattern for a 45, 45, 90? 1 square root of 2, right? Do I have any negative values here? The x, right? This x value is going to be negative. So, okay, we labeled our triangle. We're good to go. Cosecant. Oh, I don't remember. What does cosecant go with?
Adjacent over hypotenuse.
Okay, it goes with sine, right? Sine is opposite over hypotenuse, so cosecant's going to be... All right, so the cosecant of theta is hypotenuse over opposite. Yeah? So what is it? This is the 45 we're talking about. It's root 2 over 1, which is root 2. Good. A lot of little stuff to do here and there, yes, but not terribly difficult.